Let's begin with the next part of current electricity. Now, what we are going to see is some advanced designing of your current electricity, how are different components which are used. I mean, let's say we have tube light, heaters, geysers. How do we exactly connect them? Okay, and the basics behind it, what is there, that will be again there in the second chapter, that is magnetic effect. We'll only discuss the basics in this particular chapter. So in the last session we had seen about resistance. Okay, now any device it may be, whether it's let's say a bulb or iron or a geyser or a refrigerator, air conditioner, or any material, let's say copper, aluminum, gold, all of them will have some amount of resistance because atoms and electrons are present everywhere. Okay, so they are conductors, but uh, even they will have resistance, but the resistance will be definitely less as compared to that of your non-conductors. Non-conductors have a very high resistance, hence the electrons cannot move. Okay, for example, rubber hai. So rubber is a bad conductor because the electrons cannot flow through the rubber. But as compared to it, uh, from your metals, they can easily pass. Okay, so the resistance can be of any device. So whenever I talk about resistance, I will always talk about a device. अभी हर डिवाइस को लेट्स से फैन है, ट्यूबलाइट है, बल्ब है, नॉट बल्ब, फैन है, ट्यूबलाइट है, फिर या तो एसीज है, गीजर्स है, इन सबको मैं डायग्राम में नहीं बना सकता. So what we do is we represent it with the help of a symbol. Okay, and what is the symbol for resistance? The one that I have just made in front of the resistance. See this one. Okay, how do we make it? Simple enough. Just draw a straight line, zigzag few lines, let's say three or four zigzag lines. Okay, just like your mountains, but it represents any device. So let's say in a diagram, if I want to uh, put any device, I will always make the use of the word that is called as resistance. Okay, now there are two ways in which multiple resistance or multiple devices can be connected. Okay, those are called as series circuit and the parallel circuits. Okay, both the diagrams are in front of you. Just have a proper view of how I am explaining you. Okay, battery. Okay, this is the current which is flowing through the circuit. I hope now everyone remembers this is the conventional current. ये positive से negative end पे जा रहा है. Similarly over here, battery positive end से negative end पे current जा रहा है. Okay, now just have a proper look at what is happening in a series circuit and what is happening in a parallel circuit. Okay, so in series circuit, what we observe is, just have a look. This is the first resistance and this is the second resistance. Okay, so I just name this resistance as R1 and I name this resistance as R2. Okay, similarly I have the same resistance. ये वाला ही resistance जो है मैंने यहाँ पे use किया है. So let's say this is R. This is R1 and this is R2. Getting this part? Now let us understand the difference in how we have connected these two resistances. Okay, if you can see, I have just named some letters A, B, C, and D. Okay, now what is AB? AB is nothing but the first, or AB are A and B are the 2 points for the first resistance, that is R1, and C and D are the points for the resistance R2. Means कोई भी एक device का there are always 2 ends, बराबर. So वो दो एंड को हमने कनेक्ट किया हुआ है। सिमिलरली लेट्स से कभी बल्ब भी था, तो बल्ब का भी दो एंड्स होता है, तो वो दो एंड्स को हम लोग दो अलग टर्मिनल्स पे कनेक्ट करते थे, पॉजिटिव एंड नेगेटिव पे। नाउ see how there is a difference in the way I am connecting the two circuits. Okay, end A of the first resistance is connected to the battery, that is the positive end of the battery. End B is connected to end C, that means point B is connected to point C. Now point B is of the first resistance, point C is of the next resistance. Okay, I'll again repeat. Point A is directly connected to the positive terminal of the battery. Point B is connected to another point, that is C, of another resistance, that is of the second resistance. Point D of the second resistance is directly connected to the negative end of the battery. Now always remember, these wires, all these wires should not be taken into consideration. Means what I'm saying is, this resistance or point, the second terminal of R2 is directly connected to the battery. First terminal of R1 is connected to battery. Okay, this is connected to positive end and this is connected to the negative end. Okay, now see the difference in the second diagram. Same resistances, end A is connected to the positive terminal of the battery. Okay, end B, if you look at end B, it is connected to, I told you, just don't see the wires, just see how the connections are made. So this is a wire, it is connected to the negative terminal of the battery. So end A is connected to the positive terminal, end B is connected to the negative terminal. End C, again, if you observe, see, this is a wire, positive end of the battery. End D, positive end of the battery, negative end of the battery. ओके, अब तुम बोलोगे कि सर तो इसमें पॉइंट बी एंड पॉइंट डी आर दे कनेक्टेड? यस, दे आर कनेक्टेड बिकॉज दिस इज नथिंग बट अ वायर, बराबर. बट हाउ विल द करंट फ्लो? द करंट विल नॉट फ्लो फ्रॉम डी टू बी, बराबर, क्योंकि बी से भी करंट आ रहा है, तो करंट डी से बी में नहीं जाएगा. Okay, now that is the second point that I wanted to bring up is, in your parallel circuit, if you observe at this particular junction, that is over here, at this point, exactly at this point, if you observe, the current is getting divided. Okay, what is happening is a very important point, that the current gets divided. Current gets divided. Is that happening in the series circuit? Let's see. So in the series circuit, see, is there any split in the wire? Is there any split in the wire? No, there is no split in the wire. Here we have split in the wires. Okay, ऊपर भी जा रहा है, नीचे भी जा रहा है. ठीक है, it's just like, let's say suppose if you have water और ये दो पाइप्स है, ठीक है, तो वाटर दोनों पाइप में डिवाइड हो गया. ठीक है, यहाँ पे ये एक ही पाइप कंटिन्यूस चल रहा है. सो हियर द करंट इज नॉट डिवाइडेड एट ऑल. सो व्हाट आई से इज, हियर द करंट इज डिवाइडेड and here the current is not divided. So let's put up this point. Current gets divided in your parallel circuits, and the current, what we say is, current remains the same. Current remains the same in the series circuit. Okay, the first very important differentiation here, the current gets divided in the parallel circuits, but the current does not divide in the series circuit. Second very important point, when I told you that point A and point B Okay, when I told you that the point A and the point A is connected to the positive terminal, point B is connected to the negative terminal, point C is connected to the positive terminal, point D is connected to the negative terminal. So what I am saying is, in this case, both the resistances R1 and R2 are directly connected to the battery. Okay, so the point that comes up over here is both resistances, or all all resistance are connected between two common points. Okay, now see this, all resistances are connected between two common points. Now this two common points means two common points. Now the two common points means nothing but that, let's say this C and this point A are connected at this yellow point. Similarly, B and D are connected again to this yellow point. Okay, or the other way to look at it was that both of them are directly connected to the battery. ये direct connection battery को मिल रहा है. ठीक है, but see in this case how are the resistances connected? A वाला point positive पे, B वाला is not directly connected to the negative end. It first goes to C and then D is connected to point to the negative terminal. So what we say in this case is, here the resistances are connected one after the other. Resistances are connected end to end. Okay, what do we mean by end to end? End to end connection means one end of the first resistance is connected to the other end of the second resistance. Hence we say that the resistances are connected end to end. ठीक है, अब यहाँ पे एज आई टोल्ड यू, देखो इस दोनों को सेम बैटरी मिल रहा है, यहाँ पे दोनों को सेम बैटरी मिल रहा है, बराबर. सेम बैटरी मतलब इसका पॉजिटिव ए को कनेक्टेड और सी को भी कनेक्टेड, इसका नेगेटिव बी को भी कनेक्टेड एंड डी को भी कनेक्टेड. So this entire resistance can take up the battery. The second resistance can also take up the battery, that is energy from the battery. But here B is not connected directly to the battery. B battery को connected नहीं है, B C को connected है, and then D is connected to the battery. So what we say in this case is, parallel circuits have direct access to the battery totally, but series circuits don't have the direct access to the battery, or both the resistances don't have the direct access to the battery. Okay, in other words what we say is, in parallel circuits battery indicates potential difference. So we say that potential difference remains same in parallel circuits here. The potential difference remains the same. Why I am saying this is because the potential difference, that is both the resistances get the same battery, but here the potential difference changes for resistance. Now, why do I say it changes? Why do I say that the potential difference changes is, just have a look at this. Okay? The first the first terminal A is connected to the positive end and B is not directly connected to the negative end of the battery. C point is not connected to the positive end of the battery, but it is connected to point B. So both the resistances don't have direct access to the battery. Hence we say that the potential difference changes. अगर वो directly connected होता, then I say that the potential difference remains the same. Means if the resistance was directly connected to the battery, then the potential difference remains the same. But since it is not, we will say that the potential difference is changing. Okay. Now, very simple way to remember this is पैरेलल सर्किट्स में हमेशा देखो यहाँ पे बाइफर्केशन आया ना, बाइफर्केशन आया मतलब इनका करंट डिवाइड हो जाएगा. सिंपल वे टू अंडरस्टैंड. और अगर इसका करंट डिवाइड हो रहा है तो सीरीज सर्किट में करंट रिमेन सेम. एंड इफ करंट रिमेन सेम, पोटेंशियल डिफरेंस चेंजेस. एंड यहाँ पे अगर पोटेंशियल डिफरेंस चेंजेस तो हियर द पोटेंशियल डिफरेंस रिमेन्स द सेम. Okay, now there is one problem in series circuit as against the parallel circuits. Not one, there are many problems. We'll come to it one by one, but right now whatever is required for me, I'll just tell you. Suppose what happens is, let's say the resistance, that is resistance R2 stops working in both the cases. R2 has stopped working. Okay, now if R2 has stopped working, matlab now there is a gap. R2 is not there into picture at all. Can the current flow in this case? यहाँ से यहाँ पे आया, R2 is not there, there is a gap. If there is a gap, finish. Okay, that means if one of the resistances breaks in between, then the entire circuit collapses. But what over here, if R2 is gone, still I have one option. The current can flow through this path and complete the circuit. Always remember, if your circuit is incomplete, then the resistance or the bulb, they will never glow, or the resistance or the object will never function. Barabar? So here what is happening is, let's say this is gone out of picture. If this is gone out of picture, that means now there is no connection between the battery. जाएगा कहाँ? यहाँ से current आया, there is no way to move ahead. So then in this case there is no flow of current only. So the entire circuit collapses. But here, even if this breaks, doesn't matter, the current can still flow, in the upper half of the circuit. Okay, so this is the disadvantage of having a series circuit, and advantage of having a parallel circuit, that even if the one of the resistance breaks, the entire circuit will not collapse. Okay, but still series circuits and parallel circuits both are used. ऐसा नहीं है कि series circuit use नहीं होता है. Let's say वो जो decoration lightings वगैरह जो होता है दिवाली में, वहाँ पे you will observe that there are series connections also. Okay, sometimes one bulb breaks and the entire circuit goes away, but to get you a colorful effect, series circuits are also present. Barabar? So what is the differentiating point? That last point of the series parallel circuit was that the circuit breaks if one of the resistance stops working. Here the overall circuit remains unaffected if one of the resistances stops working. Okay, now there is a formula for series and parallel circuits that we have to remember, and after that we will solve the numericals also, and the derivations of the series and parallel circuits also I am giving to you. But right now, before solving the formulas, only remember the overall formula. Derivations, again, you may have to you may have to just see the video twice, thrice, so that you get a perfect way in how the answer has, or how the derivation has to be done. Okay, let us see for a series circuit and then for a parallel circuit. Okay, so let's say I have just made a small series circuit over here, which contains a battery of 10 volts, that is having a potential difference 10 volts, and two resistances of 5 ohms each. Okay, two resistances of 5 ohms each. Now, what is the exact formula, or let's say I'll just name this as this is resistance R1 and this is resistance R2, and this is a battery. Let's say it has a potential difference V. Okay, and let the current which is flowing through the circuit, let it be I. Okay, now the formula for the resistance, or rather, let's say when the resistances are connected in series, पूरे circuit का the entire circuit resistance is, that is, for this particular circuit, the total resistance of the circuit is nothing but the total of R1 plus R2. That is, R1 plus R2 is the total resistance of the circuit. How it has come up, I'll just come on to that particular logic. You have to derive this formula also. Getting this? But what is the formula? Formula is RT is equals to R1 plus R2. Always remember what you have to derive, and only after that going for derivation. Never try to go the other way around. Okay. Now, let us see how this formula has come up. So before going on to that, so if I tell you what is the total resistance of the circuit, the total resistance of the circuit RT is nothing but equals to 5 plus 5, that is nothing but 10. The total resistance of the circuit is nothing but 10 ohms. ओके, बिकॉज दोनों 5 है, तो 5 plus 5 10. तो अगर किसी ने मुझे पूछा व्हाट इज द टोटल करंट फ्लोइंग थ्रू दिस पर्टिकुलर सर्किट, आई विल यूज ओम्स लॉ. सो व्हाट इज ओम्स लॉ? V is equals to IR, that is my Veer. Okay, I will take the total resistance. Total resistance is 10, voltage is 10, so 10 equals to I into 10. So the value of I is nothing but 1 amperes. 10 नीचे जाएगा, तो पूरे सर्किट में करंट कितना जा रहा है? करंट जा रहा है 1 amperes का. Okay, now let us understand how this term came up. RT is equals to R1 plus R2. ये कहाँ से आया? अब बस इसको देखना है हमको कि ये कहाँ से आया. ठीक है, चलो let's see. So first one, अभी इसमें हमको करना क्या है? हमने देखो लास्ट स्लाइड में क्या देखा था? लास्ट स्लाइड में हमने ये देखा था that the potential difference changes. Sorry, the potential difference changes for a series circuit, but the total current remains the same. Okay, now if the potential difference changes, ओके, यहाँ पे मैं क्या करता हूँ, इंस्टेड ऑफ टेकिंग दिस 5 ना, लेट अस टेक इट सम अदर वैल्यू सो दैट वी अंडरस्टैंड इट बेटर. 5 में वापस कंफ्यूजन आएगा. सो लेट्स से आई टेक इट एज, चेंज कर देता हूँ इसको, 4 and 6 कर देता हूँ, सो दैट यू अंडरस्टैंड द लॉजिक वेरी वेरी इजीली. सो उसको 4 6 कर दिया, सो टोटल रेजिस्टेंस को 10 ही रख दिया है, सो टोटल करंट फ्लोइंग इज नथिंग बट 1. ओके, नाउ as I told you that the potential difference is not the same for R1 and R2. Why? Because R1, simple logic, R1 is not directly connected to the battery, R2 is not directly connected to the battery, so दोनों का potential difference is different. ठीक है, तो अब हम क्या करेंगे? Okay. So what I say is, let the potential difference of the first resistance, since R1 and R2 का different है, So I say that let the potential difference of the first resistance का potential difference, let it be V1 and let V2 be the voltage or the potential difference of R2. ठीक है, समझा क्यों किया? Because voltage or the potential difference is different for R1 and R2. दोनों का potential difference is not same. But I know that in this circuit there is only V1 and V2. So V1 and V2 का total value should be equal to 10 क्योंकि बैटरी टोटली मेरे पास 10 का अवेलेबल है ना, बराबर? तो अगर ये बैटरी इज 10 तो V1 प्लस V2 का वैल्यू शुड बी इक्वल टू 10 क्योंकि ये दोनों को मिला के मेरे को 10 मिलना चाहिए बिकॉज 10 इज द मैक्सिमम वोल्टेज दैट आई हैव और द मैक्सिमम पोटेंशियल डिफरेंस दैट आई हैव बिकॉज दैट इज द ओनली सोर्स ऑफ एनर्जी. And since there are only two resistors, so the total voltage, that is V, should be equal to the values of V1 and V2 because they are the only voltages over here. So what I say is the total voltage is nothing but equals to V1 plus V2. Okay, now we have seen a point that in the earlier slide that the current remains the same for both the resistance. And what is the current flowing through both the resistance? The current flowing is I. Okay, and we know that the value of the first V1 will be equals to V is equals to IR. तो V1 का वैल्यू क्या होएगा? V1 का वैल्यू होएगा I into current remains same and the resistance is R1. बराबर. नेक्स्ट सेकेंड वाले का इट विल बी I into R2. ओके, गेटिंग दिस पार्ट. अब ये दोनों टर्म्स में से व्हाट आई कैन से इज I इज कॉमन R1 plus R2. Okay, now as I told you that the current remains the same, that is I, potential difference is V. and समझो अगर ये दो रेजिस्टेंस की जगह पे I had this resistance RT, मतलब ये दो R1 plus R2 ना होके if I only had one resistance, that is द टोटल रेजिस्टेंस, मतलब यहाँ पे डबल डबल रेजिस्टेंस है, ये डबल डबल रेजिस्टेंस नहीं होता और सिर्फ एक ही रेजिस्टेंस होता. लेट्स से समवट लाइक दिस, ये दोनों रेजिस्टेंस की जगह पे आई ओनली हैव वन रेजिस्टेंस. ओके, तो ये दोनों रेजिस्टेंस को हटा के मैंने एक ही रेजिस्टेंस लाया. लेट्स से दैट इज आरटी, दैट इज टोटल रेजिस्टेंस ऑफ द सर्किट. ओके, तो करंट जा रहा है I, पोटेंशियल डिफरेंस है V एंड द करंट इज नथिंग बट RT. ठीक है, अब इफ दिस इज द सर्किट, मतलब ये दोनों रेजिस्टेंस को हटा के अगर मैंने एक रेजिस्टेंस लगा दिया होता, देन what by Ohm's law I can say that V is equals to current flowing is I and the total resistance is RT. तो वीर वाले फॉर्मूला के हिसाब से I can say that V is equals to I times RT, that is R total. If you carefully observe, दोनों जगह देखो V I आ गया है, I cut. So what is the formula for RT जो मैंने बोला था? RT is equals to R1 plus R2. देखो वो फॉर्मूला मुझे आ गया है, RT is equals to R1 plus R2. This is the formula for total resistance in a series circuit. Okay, always remember, यहाँ पे हमने चालू कहाँ से किया है? चालू वहां से किया है कि potential difference is the total of both resistance का potential difference. ठीक है, both the resistance have different potential difference, लेकिन दोनों का total will be equal to that of the source of the battery. ठीक है, अब यहां से देखो हम लोग क्या करते हैं ना, we can calculate the current सॉरी वी कैन कैलकुलेट द पोटेंशियल डिफरेंस, दैट इज हम लोग V1 का वैल्यू निकाल सकते हैं एंड V2 का वैल्यू निकाल सकते हैं। ये जो आया ना यहाँ पे V1 V2, अब यहाँ पे देखो हमको RT का टोटल बाय कैलकुलेशन कितना मिला था 10 बराबर, V इज इक्वल टू IR और करंट कितना मिला था 1 बराबर। नाउ लेट अस सी, now we can also calculate these values, that is V1 and V2. Okay, let us calculate that. So how do we do this is somewhat like this. We have the total current with us, मतलब ये जब RT का वैल्यू हमने निकाला था, that was R1 plus R2 that we have got from this formula, उससे हम लोग ने टोटल पहले निकाला था, वो मैंने तुमको बताया था। So RT is equals to 10 ohms, that is 4 यहाँ पे और 6 यहाँ पे। okay, अब दोनों resistance में से if you observe the current flowing is same, that is the funda of series circuit, that the current remains same। okay, that means the first resistance R1, ये जो मेरा R1 था, this is my R, this is my R, so let's say this is R1 and let's say if this is R2, okay, so the current which is flowing through R1 and the current which is flowing through R2, let us calculate, so is same, that is 1 amperes का मेरे को total current मिला है, it flows from both R1 and R2। so using Ohm's law, let us calculate what is the value of V1 and V2। so what is V1? V1 will be equals to, V1 is equals to V, that is IR, लेकिन I remains same but R1 का value is different, so V1 is equals to IR1। what is V2? V2 is equals to IR2। okay, now see this, what is the value of I का value हमको मिला था 1, ये रहा, value of I is 1 multiplied by R1, what is the value of R1? 4, so that is nothing but equals to 4 volts, this is the value of V1। similarly, what is the value of V2? V2 is equals to 1 multiplied by 6, which is nothing but equals to 6 volts V2। ओके, तो अब देखो ये वोल्टेज जो है दैट इज द पोटेंशियल डिफरेंस, जो 10 ओम्स 10 वोल्ट्स का पोटेंशियल डिफरेंस था, इट हैज डिफरेंशिएटेड इटसेल्फ एज 4 वोल्ट्स इसको गया एंड 6 वोल्ट्स इसको गया। V1 V2 का वैल्यू इज डिफरेंट बिकॉज द रेजिस्टेंस वैल्यू इज डिफरेंट। ओके, सो that's why we say that the potential difference changes in a series circuit, ये दोनों का टोटल मिला के, तो V1 का वैल्यू अलग है और V2 का भी वैल्यू अलग है। ओके, नाउ वी गो ऑन टू द नेक्स्ट सर्किट, दैट इज पैरेलल सर्किट्स। नाउ सी व्हाट हैपेंस इन द पैरेलल सर्किट। ठीक है, अब इसमें आंसर क्या आने वाला है ना, वो भी मैं तुमको पहले से बता देता हूँ, सो दैट you know what you have to derive। so the answer is somewhat like this, 1 upon RT is equals to 1 upon R1 plus 1 upon R2। अब इसका मतलब क्या, यहाँ पे the total resistance का value is equal to the sum of the reciprocals। 1 upon R1 plus 1 upon R2 will be the value of 1 upon RT। now what is RT? RT का मतलब ये दोनों रेजिस्टेंस हटा के अगर एक रेजिस्टेंस डाला दैट इज RT, तो क्या होएगा, ठीक है, वो हम लोग डिराइव करेंगे। तो सेम मैंने लिया हुआ है। ओके, लेट्स टेक दिस एज 4 and 6 whatever I have taken in the earlier circuit। आंसर में भी डेसिमल में आएगा, चलेगा, मेरे को उससे लेना देना नहीं है, बट द कंसेप्ट हैज टू बी अंडरस्टूड। सो लेट्स से दिस इज R1, this is R1 and let's say this is R2। okay, now you have to derive this, वो तुमको ध्यान में होना चाहिए। अब ये कैसे आएगा उसको देखते हैं। यहाँ पे मैंने क्या बोला था, R1 is directly connected to the battery। why? because if that let's say this point is A, तो ये A बैटरी को कनेक्टेड है और ये सपोज B पॉइंट है, तो ये भी बैटरी को कनेक्टेड है। सो R1 is directly connected to the battery, R2 is also directly connected to the battery। but what happens over here is, let's say if the current flowing is I, करंट डिवाइड हो जाएगा, करंट यहाँ पे आके करंट डिवीजन स्टार्ट हो गया, तो मतलब दोनों को डिफरेंट डिफरेंट करंट्स मिलेगा, बराबर। अगर डिफरेंट डिफरेंट करंट्स मिलेगा, सो आई से दैट इसको I1 मिलेगा और इसको जो करंट है वो मिलेगा करंट इसको मिलेगा I2. Okay, so what I say in this case is the current is splitting और ये equally split होगा. ठीक है, मतलब समझ लो अगर पानी यहाँ से आ रहा है, if the water is coming here, it will split. Okay, that means the total current that I have, that is I, will split into two currents, that is I1 plus I2. The total current that I have will split into I1 plus I2. Okay, and with the formula VIR, that is V equals to IR, I know that with the formula VIR, I can say that I is nothing but equals to V by R. Okay, now for both the resistances, I have told you that the potential difference remains the same. Let the potential difference this be V. दोनों के लिए potential difference is V. बराबर. So that means I1 का वैल्यू क्या होगा? I1 का वैल्यू होगा, I1 का वैल्यू होएगा, I1 is nothing but equals to V upon R1, and this will be V upon R2. Okay, now this I is the total current, and what will be the total current? मतलब total current हम कैसे निकालेंगे? ये सर्किट को अगर हम कुछ ऐसा करते कि ये सर्किट में ये टोटल सर्किट में लेट्स से व्हाट आई डू इज, ये दोनों रेजिस्टेंस को हटा के अगर मैं एक रेजिस्टेंस डालता, मतलब इन दोनों को हटा के मुझे एक रेजिस्टेंस डालना हो, तो वो सर्किट कैसा बनेगा? जिसका वैल्यू उन दोनों के जगह पे, मतलब जो भी उनका वैल्यू हो, लेट्स से R1 R2 मिला के इन पैरेलल इज सम वैल्यू, वो वैल्यू का मैं रेजिस्टेंस यहाँ पे डालूंगा, दैट इज कॉल्ड एज द टोटल रेजिस्टेंस ऑफ द सर्किट. वो कुछ भी वैल्यू हो सकता है, वो इसमें उसका टोटल नहीं होगा. मतलब तुम बोलोगे कि उसकी जगह पे 10 डालो तो वो गलत है. इट इज नॉट 10 बिकॉज द रेजिस्टेंस विल बी समथिंग एल्स. वो हम लोग यहाँ पे देखेंगे. तो इन दोनों को निकाल के अगर मैंने कोई एक रेजिस्टेंस डाला, so that resistance I will say that that resistance is RT. We have to get the value of RT. Okay, so let's say this is the potential difference battery, the current flowing through the circuit is I. So what will be the formula for I is equals to V upon R. तो यहाँ पे ये हो जाएगा V upon RT. Okay, now understand this. Here potential difference is same. जैसे मैंने बताया था, potential difference remains the same. V. Okay, so what I can do over here is I can take V common. ब्रैकेट के अंदर आएगा 1 upon R1 plus 1 upon R2, and this is nothing but equals to V upon RT. VV दोनों जगह पे सेम आ रहा है, that is VV is same in both sides. So the final formula which I am left with is, what will be the total value? The total value will be 1 upon RT is equals to, I'll just write it clearly. Okay, so 1 upon RT is equals to 1 upon R1 plus 1 upon R2. ओके, ये देखो, ये जो मेरे को चाहिए था मेरे को मिल गया. 1 upon RT is equals to 1 upon R1 plus 1 upon R2. Okay, now the values which I have in front of me, let us use that and calculate the values of I1, I2. Okay, and याद रखना दोनों के लिए potential difference is same. Getting this part? So if I want to, let's say, calculate the value of RT, what is the total resistance of the entire circuit? See, how do I calculate? The total resistance is calculated as 1 upon RT 1 upon RT is equals to 1 upon 4 plus 1 upon 6. Okay, 6 and 4 का LCM होगा 12. So this becomes 3 plus 2 upon 12. This is the value of 1 by RT, and this is nothing but 1 by RT is equals to 5 upon 12. Now a very important point over here. After this, everyone makes a mistake that they keep the answer over here. It is not that. If I want to calculate the RT, I will have to inverse this value. So it is nothing but 12 by 5. So what is this? This is nothing but 12 by 5, which is nothing but equals to 2.4. This is the value of RT. That is 2.4 ohms. अब देखो क्या हो गया. अब देखो क्या होगा. यहाँ पे सबसे important lesson हमको मिला है. That is, whenever we connect the resistances in parallel, जब उसको मैंने पैरेलल में कनेक्ट किया तो देखो क्या हो गया. The total resistance became the total resistance became 2.4 ohms. मतलब ये R1 और R2 को अगर तुमको हटाने का है एंड दे आर कनेक्टेड इन पैरेलल, तो तुमको RT का वैल्यू कितना लगेगा. तुमको RT का वैल्यू जो है, तुमको RT का वैल्यू लगेगा 2.4 ohms. बट अगर तुम सीरीज कनेक्शन रख रहे हो फॉर द सेम रेजिस्टेंसेस और तुमको ये दो रेजिस्टेंस को चेंज करना है, यू विल हैव टू पुट अप अ रेजिस्टेंस ऑफ 10 ohms. See the difference. So what is happening is if the resistances are connected in series, the total resistance increases, and if they are connected in parallel, the total resistance always decreases. इसके लिए we always avoid having the series circuit because resistance increase हो रहा है. और अगर resistance increase हो रहा है with the formula of potential difference, that is V, हमको ज्यादा V का वैल्यू लगेगा. That is, if V is equals to IR, ठीक है, अगर V equals to IR है and if the value of resistance increases, potential difference भी ज्यादा लगेगा. मतलब you will need a battery of higher potential difference to tackle a series circuit as compared to that of a parallel circuit. Okay, but both of them have their significance in wherever required. Okay, now let us calculate the values of I1 and I2 in this case. Okay, so okay, so let us calculate the value of I1 and I2. So I1, as per the formula for V, I1 is equals to V by R1. What is the value of V? V का value I know that it is nothing but 10. So 10 upon R1 का value is 4. So 10 upon 4, the answer is nothing but 2.5. Let's say what is the value of I2? I2 का value is equals to V upon R2. If it is V upon R2, then it is equals to 10 by 6, which is nothing but equals to 5 by 3. And 5 by 3 value will be just about 1.66, or rather if I just round it off, it is 1.67. Let it be in decimals, doesn't matter. Okay, the total of I1 and I2 which I have, that is I is nothing but equals to I1 plus I2 because the current gets divided. So what value do you get? You get the value as 2.5 plus 1.67. So that is nothing but equals to 4.17. Okay, now see the values of current that you require in this case. If you have two resistances connected in parallel, the total current that you will require is 4 amperes, and in this case you will require a current of 1 amperes only. or the total current is nothing but 1 amperes. Getting this part? So this is the difference between the series circuit and the parallel circuits. That is, the total of the current increases, that is fine. But what happens is my overall resistance decreases, and if the overall resistance decreases, the load on the circuit also decreases. Okay, so understood this part? This was all about your series and parallel circuits. So in the series circuit, what we can do is we can include one point, that is the total resistance of circuit increases. This is in series circuit. And in parallel circuits, we can say that the total resistance of the circuit reduces. Okay, so these are your differentiating point in series and parallel circuits. In the next video, what we will see is the difference between, or what do you mean by the terms resistivity and heating effects of electric current, and few examples of how to solve series and parallel circuits.